All right, so something you'll notice about a kite is you have one long diagonal, and then you have a shorter diagonal. And the longer diagonal that connects the big end to the little end is what I like to say, because there'll always be one side that's got these two are shorter than these two. Whatever. Anyway, this long diagonal bisects the entire kite, bisects everything about the kite. So it's a line of symmetry is all it is. It's going to bisect angle C. This would be the entire angle C. It's getting cut up into two equal parts. Same thing with angle D. Sliced in two different equal angles. Then this diagonal from A to B is also getting bisected, and that's why you have the same lengths there. Now, going on, talking about our symmetry part, angle B and angle A will be congruent because this half of the kite is symmetric to this half of the kite. So this value, whatever value that is, the length, is the same as this length. Same thing down here. I've got DB is going to be congruent to DA. All of this is happening based on this line being a line of symmetry. Also, the diagonals are perpendicular to each other. They cross at a 90-degree angle. So what this is going to allow you to do, you'll know that all four of these angles are always 90 degrees. If I'm given this angle, then it's easy to figure out what this angle here is. Now, what you need to make sure you don't understand, or that you understand, is this diagonal does not bisect our angles A and B. That's not what happens. So I can't just simply say, okay, well, if I know what this angle is, I know what that is. No, I might need to know what this angle is, and then might need to know what the whole angle A is or something to figure this part out. But we'll get into that. I just want to give you a good overview of what a kite looks like. Here we have a blank kite, and I'm going to give you an example of the types of problems you'll see. For instance, easy types of problems, you might see, hey, this is 20 degrees, and it might want to know what this angle is. Well, if that's 20 degrees, then this would be 20 degrees, right? And then we know these are all 90, right? Those are all 90 degrees. That looks stupid, so I'm just going to put 1 there. So those are all 90 degrees. Well, if I've got this is 20 degrees and that's 90 degrees, then I can say, okay, well, I know that this angle up here is going to be 70. If that angle's 70, then this angle's 70, no matter what. Okay, but even though I have that these are right angles, and then that's 70, and this is 20, and that's 20, I really still don't know what these angles are. I don't have enough information right now. I would have to be given something that says this is what this angle is. So let's just go ahead and let's call that angle 30 degrees. Now that that's 30 degrees, now I can figure out the rest of it, right? And I could say, okay, well, that's 30, then this has to be 60 degrees, which makes that 90, or because we got that 90 there at the R. Remember, don't forget that's 90. So if that's 30 and 60, then this is 30 and 60. And then there's all my angles, okay? But it might not happen that way. I might not be given, all that information that I was assuming. So let's go ahead, let's get rid of all that. All right, let's say that I was given that this is 40 degrees, but then I'm given that this entire angle is 75 degrees. And I'm just making something up. Well, if I wanted to find this angle, and I know the entire angle here is 75, well, this entire angle is also 75. So that angle would be 75 minus 40, which would be 35 degrees. From here, I can fill it all out. I can do the entire triangle, or the entire kite, because it's basically broke up into 4 right triangles. If that's 35 degrees, I've got triangle sum, 90 and 35, right? That's going to leave this to 55 degrees. Anything I have down here, I can go ahead and use I can use symmetry to just flip it up there. I'm just copying everything down. Well, now, I've got part of my right triangle here. I got a 40 and a 90 and a 40 and a 90. If I need to know this angle, 90 minus, or 180 minus 90 minus 40 is 50. And I know that don't make a lick of sense because this is going to be, that's two acute angles. And actually, it's one big acute angle, so 50 and 50, those numbers wouldn't make sense. I'm just saying, with the angle relationships, that's how I could find those. Obviously, this is not a 100-degree angle. These are not 250-degree angles. They're probably more like 225-degree angles that makes 150-degree angle. But you can kind of see where all the relationships are. So that deals kind of with the angles. It kind of helps us with the angles, and you should be able to use that information based on and previous knowledge to answer anything we have about the angles. The other types of questions you'll have that this is 10, and it'll ask you what this is. Well, obviously it's 10, right? And that's not the one I wanted. So obviously it's 10, right? And then it might say this is 5. So then if that's 5, that's 5, obviously. Whatever this is, if that's 3, then that's 3. And obviously the numbers don't make any sense right now. I'm just throwing numbers out there. But you should understand the symmetry part of it. This is cutting everything in half, so it's symmetrical. The other things you might have questions that once you use Pythagorean theorem. So you might be saying, well, this is 6, this is 9, and it wants to know what this is. You'd use Pythagorean theorem, so just remember a squared plus b squared equals c squared, and that will give you this missing side, and it also give you this missing side. But you couldn't figure out anything, based on what we have here, you wouldn't be able to figure out anything on this side. So you'd have to have stuff that relates to this side. Whether it be, a hypotenuse on one of these little smaller right triangles, because remember these are all right triangles. Might be that that's 5, and you'd have to know that that's 5. Obviously that couldn't be 5 if this is 6, so let me use a different number. Guys, when I make up numbers, don't look too far into them, okay? We'll say that's 8, and that's 8. Well, you could still use Pythagorean theorem because you know that's 6. You use Pythagorean theorem and find out this part where you'd have a squared and a c squared, and you'd be having to go back and find b. But anyway, that's old skills. I just kind of wanted to make sure you understood how the workings of a kite and how the numbers relate. And really, I don't think you're going to have too much trouble with these. It's just making sure you understand what works and what doesn't, what's going to be symmetric. Really popular questions with kites are going to be, let me get rid of all this. You don't need that either. The more popular questions are going to be, well, I'm given this whole angle and I just need to find part of this. You know what I'm saying? And it'll be like, okay, well, this is, and I used the wrong symbol there. So maybe, like I said, I had 35 degrees, I don't know. And this whole thing, we'll say it's 110 degrees. So if that's 110 degrees, and then I have that this is 35 degrees, 110 minus 35, and that's going to get you there, and you'll have that that's 65-degree angle. And again, obviously not the scale. But you would need to understand that this whole angle, creates that entire angle. Whatever this entire angle is, this entire angle is going to be symmetric to it, and it's going to be congruent.